ISRO's Chandrayaan-3 landing was, let's be honest, absolutely epic. A perfect touchdown on the moon's south pole. But it immediately makes you wonder, right? After pulling off something that incredible, what's next? What on Earth, or off it, could possibly be harder? Well, today, we're going to find out. So first, let's set our benchmark. The Chandrayaan-3 landing was a total masterclass in managing risk. I mean, think about it. A fully autonomous 15-minute descent, basically in a vacuum, using pinpoint precision braking to hit a really treacherous target. And with a global success rate for these landings sitting at around 50%, yeah, ISRO proved they have absolutely mastered deep space mechanical precision. And that brings us right to our big question. If you've already conquered the art of landing a robot millions of kilometers from home, what's the next impossible mission? We're going to look at 3 contenders from ISRO's roadmap. And here's the cool part. Each one presents a completely different and, you could argue, much, much greater challenge.
Okay, our first contender is the Gaganyaan program, and this one completely changes the game. The whole focus shifts from conquering a hostile environment to protecting the most precious cargo you can imagine, human life.
So the goal here is nothing short of monumental. We're talking about making India only the 4th nation in history to independently send its own astronauts into space. That means a 3-person crew orbiting at 400 kilometers for up to a whole week. The first crewed flight, which is planned for 2026, isn't just another mission. It is a massive, massive leap for India's entire space program. But here's where the challenge gets really fascinating. You know, low Earth orbit, it's actually pretty tame compared to deep space. The real difficulty here is the need for absolute 100% perfection. A failure isn't just losing a piece of hardware, it could mean a catastrophic loss of life. That means you need layers upon layers of redundant systems and a crew escape mechanism that has to work perfectly every single time. It's a test of systemic complexity, not just surviving a tough environment. All right, so from human safety, let's pivot to our second contender, which takes us all the way back to the Red Planet. After the just stunning success of the Mangalyaan orbiter, ISRO is now setting its sights on the Martian surface with Mangalyaan 2. This mission, slated for somewhere between 2028 and 2030, is not just about orbiting. No, this time it's all about landing. The plan is to deploy a lander and maybe even a rover to study the Martian surface up close and personal. If they pull this off, it puts India into the very exclusive club of nations that have actually operated on Mars. So what makes landing on Mars such a unique beast? It's that atmosphere. It's a total aerodynamic nightmare. It's about 100 times thinner than Earth's. So what does that mean? Well, it's too thin for parachutes to do all the work, but it's just thick enough to create scorching, intense heat when you enter. This means you need a super complex sequence of aerobraking, deploying a parachute at supersonic speeds, and then a final powered descent. In a lot of ways, this is a much harder mechanical puzzle than landing in the vacuum of the moon. And now for our final contender. We're heading to Venus, a planet that's often called Earth's twin. But, as we are about to see, it is anything but hospitable. The Chandrayaan-1 mission, planned for 2025, is all about orbiting Venus and trying to peel back its many, many mysteries. See, the planet is totally shrouded in this permanent, thick layer of clouds. So to even see the surface, the orbiter has to use a high-res synthetic aperture radar. The whole goal is to figure out what's hiding underneath and, maybe more importantly, why Venus turned into a planetary inferno. And this mission, wow, it highlights a completely different kind of problem. With Chandrayaan, the main challenge isn't about navigation or control. It's about pure, raw survival. Venus is, you could easily argue, the single most hostile planetary environment in our entire inner solar system. This mission pushes material science to its absolute breaking point. It is a battle against the fundamental laws of physics itself. So let's do a quick recap. We've got Gaganyaan, which is a challenge of human safety. We've got Mangalyaan 2, a challenge of mastering a complex landing. And then there's Chandrayaan-1, which challenges our tech's ability to just exist. So which one is the hardest? This table really lays it all out, doesn't it? It frames the different kinds of difficulty perfectly. Chandrayaan was a test of mechanical precision. Gaganyaan is a challenge of systemic complexity. Mangalyaan 2 is all about dynamic control. But Chandrayaan is in a whole other league. Its difficulty is pure survivability. The most likely way it fails isn't a guidance error, but a complete thermal or structural collapse. And there it is, that's our verdict. While all three of these missions are incredibly ambitious, Shukriyan-1 represents the most fundamental engineering challenge Israel has ever taken on. It forces engineers to design for an environment that is actively trying to destroy anything that enters it. And to put that into perspective for you, the surface of Venus is over 460 degrees Celsius. That's hot enough to literally melt lead. Your standard electronics, they wouldn't just fail, they would be cooked into absolute oblivion. And then there's the pressure. The atmospheric pressure on the surface is more than 90 times that of Earth at sea level. That is the same as being 900 meters or almost 3,000 feet underwater. Any probe sent there would need the same kind of structural integrity as a deep-sea submarine. So the fundamental challenge here, it isn't just getting to Venus or landing there. It's about designing a machine that can somehow withstand being immediately melted, crushed, and dissolved by a corrosive atmosphere. You are literally engineering for an environment that is, for all practical purposes, hellish. So how do all these incredibly difficult missions fit into ISRO's bigger picture? Well, they're not just isolated stunts or challenges. They are foundational steps in a much, much grander strategy for India's entire future in space. The agency is massively scaling up everything it does. The plan is to conduct an astonishing 50 launches in just the next 5 years. This isn't just about exploration anymore. It's about building an industrial rhythm, making access to space routine, reliable, and frequent. And this roadmap, it lays out that long-term vision so clearly. You have the first crewed Gaganyaan flight in 2026, then a Mars landing by 2030, and ultimately an Indian space station by 2035. See how each mission builds on the last? They're proving the technologies needed for the next huge step. As one analyst perfectly put it, ISRO isn't just aiming for the stars anymore, they are building the highway to get there. Every single one of these missions pushes the boundaries of what we all think is possible. They drive innovation in materials, in autonomy, and life support. They're a really powerful reminder that space exploration isn't just about reaching new places. It's about our relentless drive as people to solve impossible problems. And that leaves us with a final thought. As we get better and better at conquering the challenges in our own solar system, what impossible problem should humanity tackle next?